Okay, so first things first, I just want to chat about the different formulas that we deal with in finance, because sort of along with analytical geometry, I would say finance is probably the most heavy section in terms of formulas that you need to know. So on your formula sheet, you have got 6 formulas that you are going to have to work with. There's also another formula that we need to work with, which I'll write down in a second, that is not on your formula sheet, but you need to know. All right, so this first formula over here, this is for simple interest. Okay, simple interest is essentially when you earn interest only ever on your principal amount. Principal amount means what you started with in terms of your investment. So if, let's say, you invested 10,000 Rand, you will only ever earn interest as a percentage of that 10,000 Rand. It is not like compound interest where you can earn interest on interest, which we'll chat about in a second. So this first formula is simple interest. All the way on the other side, and this is taken directly from your formula sheet. So this is exactly how they're presented. Obviously, there's formulas in between them, but this is exactly how it's shown on your formula sheet. All the way over here on the right-hand side, this is compound interest. Okay, compound interest is where we do earn interest upon interest. So basically what I mean by that is your 10,000 Rand that you initially invested, let's say you earn 10% per year on that. After 1 year, you would have earned 1,000 Rand, which means that in your account, you have 11,000 Rand. For the next year, compound interest allows you to earn interest on the 11,000 Rand now. And so your next bout of interest will be 1,100 Rand. And so you add it onto your balance. You now have 12,100 Rand. You can now earn interest on that 12,100 Rand. And so it keeps going. Whereas simple interest will only ever be on that starting amount. You will only ever get 10% of 1,000. Even though your balance increases, the amount on which the interest is charged doesn't. Right, so that's simple and compound interest. You've been doing those pretty much since grade 9, so it shouldn't be too new. These two formulas over here are slightly new. We deal with what we call depreciation from grade 11. So this first formula here is straight line depreciation. Oof. Depreciation. And this formula over here that looks like the compound interest formula is the reducing balance depreciation. Does anyone know what depreciation is? Can anyone tell me what depreciation is? Nice, Awami. Okay. Very simply put, it's the decrease in the value. So depreciation happens with many things in life, particularly assets. Depreciation. So why does it have to be such a long word? Decrease in value. Sorry, guys. If you can't read anything I write, just let me know and I will try and fix it. So depreciation exactly is a decrease in the value. We work with depreciation a lot with assets. So, I mean, obviously we work with it in maths and like a context, but in real life it also happens. So, I don't know, take for example your cell phone. When your cell phone was brand new, it was worth the cost price that you bought it for. However, as you start to use it and you start to sort of deplete the battery life, as you maybe drop it a few times, the value decreases, and that's depreciation. Depreciation with cars, the only thing that doesn't really suffer depreciation often is housing. More times or more often than not, houses become more valuable than what they were originally worth. That's really the only sort of major asset that people own that doesn't depreciate in value. But anything, any sort of technology, equipment, like I say, your car, big assets like that, all of them are going to depreciate in value. They will not ever be worth what they were worth the day you bought it. Okay, even if you buy secondhand, because you are now using it, again, it's just going to depreciate more and more. One thing I do just want to sort of draw your attention to, and again, this is not something that's really ever going to be asked, but it's interesting to know, is that straight line depreciation, if you just think about the actual wording of it, is basically a decrease in value from its original price down to essentially zero. I realize I've used two O's there, but yes. So if a car, let's say, for example, was worth 250,000 Rand, straight line depreciation would eventually take it down to a zero value. That's not actually possible in real life. Anything is worth something, even if it's just like a scrap value, it always is worth something. And so often what we work with is reducing balance depreciation in real life, because that's more realistic. Your value will decrease and decrease and decrease, and I'll get quite close to zero, but it will never be worth exactly zero. And so reducing balance depreciation is what we use in the real world. Obviously, I can ask you either one of them, so be prepared to answer for either one of them, but just as a, I don't know, interesting point of fact. Okay, so these are formulas that you've been working with since grade 11. However, the two at the bottom here are your new formulas. So the first one, this F formula, is for future value. So this F, future value. Right, future value, you're looking towards the future, you're looking to invest in something, save up for something, whatever the case is. And so this formula is used when we talk about investments or savings or something like that. P, whoops, is present value. Whoops. Present value is looking at a current value of something, and this we work with in terms of loans. So loans, we always want to know what our present amount owed on a loan amount is. We always want to know presently what it is that is being owed to us if someone owes us money. But present value we work with when we work with loans. Future value we work with when we work with investments and savings. Now, like I said, these two formulas are the new matric formulas. One thing I just want to draw your attention to before we start working with these actual formulas is the fact that the N values, and you kind of have already been doing this with your compound and simple interest, but these N values no longer represent that number of years that it used to represent when you were in grade 9 and grade 10. These N values, I'm going to talk about both of them, represent the number of payments being made. So in the situation of an investment, how many times are you depositing money into your account? In terms of a loan, how many repayments are you making? When we start talking about balance outstanding, we use the present value formula because it is a loan scenario, but this N value will then represent how many payments we still have to make. Right, now we will look at examples of all of this stuff over the next 2 lessons, but these are just some important things to bear in mind. Another thing that you need to bear in mind is that often our compounding period is different. It'll get there eventually. We will, again, obviously look at examples. Pretty much at this level in grade 12, your compounding period will very rarely ever be annually. So we need to just bear in mind compounding periods. And we have to bear this in mind because if your interest, let's say, is 13% per annum compounded monthly, what that means is that 13% gets split up over 12 months and paid back to you each month. So your compounding period is where we pay interest in portions, I suppose. I don't know if that's the right word, but it could be monthly, it could be quarterly, it could be semi-annually or biannually or half-yearly. All of those words mean the same thing. Quarterly, let's go semi-annually. So semi-annually, biannually, half-yearly, They all mean twice a year. So your compounding period, you have to take into account with your interest, and then obviously that links to your number of payments. If in a year you earn interest every single month, that means you get 12 interest payments. If in a year you earn interest quarterly, that means you get 4 interest payments, and so on, so on. So it's just important to understand your compounding period and then be able to apply that to what effect it has on your interest and what effect it has on the number of payments that you make, whether it is an investment or a loan. The last little thing just in these last two formulas is the fact that these X values are essentially your monthly payments, either your monthly installments or your monthly deposits into your investment account, whatever it is. With regards to loans, it's your monthly repayment amount. I don't know why I said money instead of monthly, but anywho. Let's try that again. But otherwise, all of the variables are exactly as you're used to them. There's nothing new. Right, the only thing that I don't have here that you guys need to know, and this is not on your formula sheet, is how to convert between effective and nominal. Let's see if I can fit it in here. Right, so your conversion between the two is that 1 plus I effective. So your effective interest rate is equal to 1 plus I nominal over m to the power of m, or n, doesn't really matter, I suppose. N probably makes more sense, but there we go. So n, it didn't work there. Right, so this little formula in the pinky purple bubble, that is one that you need to know. You will not be given this formula. If I ask you to convert between nominal and effective, you need to be able to do that using this formula. Again, it is not on your formula sheet. It is the one and only finance formula that you do actually need to learn, and it's to convert between the two. Just in case we don't know what the difference is, effective interest rate is an interest rate per year, compounded annually. And a nominal interest rate is an interest rate that you get per annum, but then is compounded quarterly or monthly. So you'll have 13% per annum, but then the compounding period differs. It's not per annum as well. Effective is 13% per annum, compounded annually. Those two time periods match. Your effective interest rate will always be slightly more than your nominal, because if you think about it, if let's say, for example, you get interest payments 12 times in a year versus 1 time in a year, that one payment needs to accommodate for all 12 of your monthly repayments. So if your effective interest rate must match your nominal, the effective will always be slightly higher than the nominal to accommodate for the fact that nominal means more payments. So this effective interest rate is always going to be bigger than your nominal interest rate. Right, that's just a way to sort of check yourself. If you get a question of convert the nominal to effective or effective to nominal, whatever the case is, you can double check. If your effective ends up being less than your nominal, you know you've done something wrong. Okay, guys, so these are your formulas. It's what they all mean. I know this is a lot of very unneat handwriting, but this is what you need to be able to work with. Okay, so your basic interest calculations, depreciation, and then your future and present value formulas. We're going to do just examples, essentially going through all of this, understanding how to read these questions, because at the end of the day, what trips us, as I said at the start of our lesson, is understanding what information we've been given. So by working through these examples, hopefully we're going to start to pick up the language and the terminology that is used, and we can then apply that to getting our answers. Right, I'm just going to wait for like 2 seconds in case anyone wants to screenshot all of this, and then we will have a look at our first example. So like I said, we're going to go through past paper examples, because that's the best way to practice finance, so that you can see the terminologies used as you go along, but also so that you can see, like in relation to the rest of the paper, it really is not a lot, but it is easy to get marks in finance because of the fact that it really is just applying a formula, but the language is what often confuses us. Okay, so I'm just waiting for screenshots and then we'll move on. Right, and guys, don't forget, if you have any questions at any point, please just ask. You can put it in the chat, you can raise your hand, whatever you need. But please ask if you do have questions, because that's the only way I'm going to know if you need help. All right, so let's have a look. So this is from, I don't actually know what year we're in at the moment, 2024. So this was from 2 years ago, finals. In my opinion, this was a very easy finance question. You'll see now in a second. I could be wrong. I don't know. I don't particularly like finance, if I'm being completely honest. This is probably one of my trickier sections in maths. But I did think this was a relatively easy one. So we'll have a look at this, but we will have a look at some others. All right. So first things first, when you're reading a finance question, you're probably going to have to read it 2 or 3 times, to be honest. Some of the information has a lot going on in it. And so you need to sort of break down what's happening. Sorry, great toes. But the first thing that you need to decide is, what information do you have? What is the scenario? Which formulas would be most appropriate? So for example, we're just going to read the first question, then we'll go and do some analysis. 12,000 Rand was invested in a fund that paid interest at M% per annum. Immediately, there should be a little alarm bell going off telling me that I don't know what my interest rate is. And that's probably going to be what I'm asked to find. At M% per annum compounded quarterly. Again, another little alarm bell, compounding period. After 24 months, the value of the investment was 13,459 Rand. And look at that, determine the value of M. Right, what often happens with finance is it starts off with a nice sort of grade 11 level question, something like determine the interest, etc., and then we ramp up into slightly more complex problems, working with future and present value formulas. Okay, so we're going to read it again, and we're now going to actually start to identify the information we have. So first things first, we were told how much was invested. So remember, in terms of your formulas, this would be our p-value. I don't know what happened there. Now, I know it's my p-value, and I know I'm not working with future or present value, because if you have a look here, your present and your future values, again, represent investments and represent loans. Yes, this is investments, but it's not telling me anything about monthly repayments. It's not giving me any sort of indication that every single month I'm depositing into this investment account. I'm just putting it in and it's sitting there. Right, so that's my p-value. We're then told that interest is paid at M% per annum. Now, this is my I value. Obviously, I don't know what it is, but it is my I value. And I need to bear in mind that it's compounded quarterly. So what that means is I would need to take my interest and divide it by 4. But it also means that whatever my N value is, and let's say N is number of years, I would have to times that by 4, because there are 4 quarters in 1 year. So for example, if this was a 2-year period, that would be 8 payments. If it was a 3-year period, that would be 12 payments every quarter. So that compounded quarterly, very, very important. It then goes on to tell me after 24 months, so this is quite useful to me because it now gives me an indication of time. 24 months, remember, is 2 years. The value of the investment was 13,459. So this is my A value. Now, guys, whenever there is the compounded quarterly, compounded annually, monthly, whatever, you're using the compound interest formula. Because this is an investment and not an item that has depreciated, you're going to use the normal compound interest formula. And once you've identified what all your variables are and what all your amounts are, you just plug it in. So A, we know is the 13,459. P, we know is the 12,000 we initially invested. 1 is the constant, plus I, so that's my M value. But remember, because it's compounded quarterly, I need to divide that by 4. If M, say, for example, was 12%, that would be per annum, as it says there. However, we need to split it over our quarters, so we divide it by 4. And then we can close our bracket and we would raise it to the appropriate exponent. Now, our exponent, remember, talks about how many payments we make. So if we've got 2 years and we get paid every quarter, in 1 year, that's 4 payments. In 2 years, that's 8 payments. So our power or our exponent here would be 8. Again, remember, your exponent is the number of payments made, not the number of years or anything like that, the number of payments made. That changes in grade 11 and we need to be mindful of it. Right, and then what we're doing is we're solving for m. So if you struggle with these sorts of questions, this might sound like a really silly thing, but just highlight where m is, because what you know is that you need to get that alone. So I have to deal with the division by 4, the plus 1, the exponent of 8, and that 12,000. Right, first things first, get rid of that coefficient. So we're going to divide both sides by 12,000. Now grade 12s, if you want to, you are welcome to just, I don't know how to say this. You can obviously type 13,459 Rand divided by 12,000 on your calculator. That's fine. But just bear in mind, it's going to give you a really gross decimal. You can write that decimal down if you want, or you can just leave your fraction as 13,459 over 12,000. Doesn't really matter. I like to write the decimals. Why? Because I like to make my life hard. I don't know. But either way, it's up to you. So if you divide this, you get 1,12158 quadruple 3. You obviously do not need to write all of these decimals down. Write down like 4 or 5. It's not a final answer, so you should not be rounding off. But we get that, and then we've got our bracket 1 plus m over 4 to the power 8. I now want to get rid of that 8. So who can tell me how I would get rid of that exponent of 8? How do I get rid of this exponent of 8? Nice, Layla. Okay, so exactly, we 8th root it. Anytime you want to get rid of an exponent, you then do the inverse operation, which is its root. So we're going to 8th root, that gets rid of that. But remember, what you do on the left, you do on the right. It's terrible root, but whatever. We know what we mean. And we get that the 8th root of this lovely value is 1,0144. There's a whole bunch of 4s. And now all we're left with is the 1 plus m over 4. Now this is a much easier equation to start solving. We're going to subtract 1 on both sides. So we've got 0,014, etc., is equal to m over 4. And then to get rid of that fraction, I'm going to times both sides by 4. So m is equal to 0,05778, blah, blah, blah. Now, guys, remember it says determine the value of m, but m is a percentage. Whenever you are working out an I value and m value, something that represents the interest rate, it must always be as a percentage. So all you do is you times this by 100, and we get that m is equal to 5,78%. So this person, if they invested 12,000 Rand and wanted to get 13,459 Rand out of that investment, they would have to invest it at an interest rate of 5,78% per annum compounded quarterly. And that will give me my output. Right, now this was a 4 marker. Granted, our working out looks like a lot, but what you'll see as I show you the mark allocation is that mark allocations is not really for any of the working out. So your first mark allocation is for this 8 over here. So understanding how many payments you are making in the quarterly scenario. The next mark is for substituting into your correct formula. Often there are marks allocated for substitution to the correct formula. And so you using the correct formulas is obviously incredibly important. The next mark is for understanding that you needed to 8th root. And the final mark is for your answer. So as you can see, all of this working out doesn't really make a difference to your marks. Even if you didn't necessarily show the 8th root, but you got to the right answer, you'll get 4 marks because we will assume that your working out has occurred correctly. My advice, try and show each step. It just helps your marker and it helps you in actual fact. Trying to do too many inverse operations all at the same time does become quite confusing. But obviously you do what you're comfortable with. I always show all of my steps, even if they're not necessarily necessary, just because I do think that it makes the working out and your thought process easier. But I mean, you do you. All right, so this was the grade 11 level question. Like I say, relatively easy. Often it's something like this, working out I, or like an effective to nominal interest rate, something like that. But then they head into future value, present value, etc. So I'll just wait here in case you want to screenshot this, and then we'll have a look at the next one. Alrighty. Okay, so this is now where things start ramping up a little bit. On the 31st of January 2022, Tino invested R1,000 in an account that paid interest at 7.5% per annum compounded monthly. He continued depositing R1,000 on the last day of every month. He will make the last deposit on the 31st of December 2022. Will Tino have sufficient funds in the account on the 1st of January 2023 to buy a computer that costs R13,000? Justify your answer by means of an appropriate calculation. So basically, do the calculation to see whether or not he has this amount in his account, or to see what amount he has, and then you can make your conclusion. So we've read the question once. We go back now and we start to analyze all the information that we've been given. So first things first is we were told that on the 31st of January 2022, the first deposit was made, and the last deposit was made on the 31st of December 2022. Now, this seems really silly, but if you struggle with understanding how many payments are being made, count it on your fingers. Obviously, if it's a year gap, you can shorten that process. But it's really, really important that you know how many payments are being made. Because it's every month, so he makes on the 31st of January 2022 and at the end of every month. So February, March, April, May, June, July, August, September, October, November, and he pays on the 31st of December. So there are 12 payments that are being made into this investment over this period. 12 payments. We want to know if you'll have enough money in the account on the 1st of January. 31st December, 1st of January, there's no additional payment, and it's not even a day's worth of interest. So that's not something we need to stress about. So that's the time period. The next thing that we're told is that he deposits R1,000 into the account. And continues paying or depositing R1,000. So that monthly deposit, that monthly input remains consistent. The next bit of information we were told is the interest rate. Now, again, take note of your compounding period because that will be very important. Our interest rate is 7.5% per annum, but it is compounded monthly. So what that means for us is that we will need to take that 7.5% and we would need to divide it by 12. Now, guys, how you choose to write this is up to you. I always just write it as a decimal. That's my preference. So that's 7.5% divided by 12. You could just write it as 7.5% over 12. You could write it as 7... It's another way to write it. I just never know how to do 7.5 over 1,200 because 7.5% is 7.5 divided by 100. 12 times 100 is then 1,200. I don't like that one. I don't know. It confuses my brain, but you do you. There's many different ways to represent the percentage of the interest rate. I always use the first one. That's the one that I'm most comfortable with and have used since I was at school, so a lot of years. But as long as you understand it is a percentage that is then compounded monthly or whatever the compounding period is, you're fine. You do you. Okay. The last sort of little bit is we need to make a deduction. We need to come to some sort of conclusion about this whole scenario. That conclusion is, will there be sufficient funds to cover a 13,000 Rand cost of a computer? So that is our end goal. So what we're going to do is we're going to figure out how much is actually in the account after this 12-month period. Now, because this is an investment and because there are continuous deposits into this investment account, we are going to use our future value formula. So F is equal to X 1 plus I, and yeah, no, that's fine. N minus 1 all over all over I. Terrible formula, but anyways. You don't need to write these formulas down. They're on your formula sheet, so you don't need to copy them. The only thing I will say is please make sure you copy them correctly. If you write down the formula incorrectly, as I say, you often get marks for substitution into your formula. You'll lose that mark. Alrighty, so we know that every single month we're putting in 1,000 Rand. And remember, X are your monthly inputs or your monthly installments, monthly repayments if it's a loan. So that's 1,000 Rand. Then we've got our 1 plus our interest. Now remember, this is 7.5% compounded monthly, so divided by 12. I've used a lot of weird brackets here. I'm very sorry. Some strange choices were made in life. Let's just fix that. Okay, round brackets, here we go. To the power of n. Remember that power of n is your number of payments. So there were 12 payments of 1,000 Rand that we made. Minus 1 all over your interest. Didn't work. Again, this interest, you must take into account the fact that it's compounded monthly. So it'd be, again, 0.075 over 12. Never, ever forget your compounding period. If you do, you're going to mess it up. Now, as ugly as this looks, you just type this into your calculator. You have no unknowns there that you're trying to solve. You know everything. That looks like an I. This is a 1. You know everything there. There is no need to panic. You just type that all into your calculator. And what you get is a value of 12,421 Rand 22 cents. Now, remember, what we were trying to find out is how much we have in this investment and whether or not that amount will cover my 13,000 Rand laptop. Because it's not enough money. Remember, the question said, will he have enough funds? No, he won't. That's not how you spell won't. So that's also problematic, isn't it? What? Okay. We did speak about this the other day. No, we didn't speak about this the other day because I'm just imagining things, so you can ignore me. I think we spoke about it a little while ago. It wasn't as recent as I thought it was. The fact that if your question is asking you to make a conclusion or to state whether something is true or not, you do actually need to make that conclusion. So again, 4 marks, you'll see that one of these marks is for your final conclusion, for concluding that no, he will not have enough money. Right, the rest of your marks, conclusion. Firstly, your interest rate, understanding that it needs to be divided by 12. A mark for your exponent. Often this is how marks are allocated for I and for N in your future and present value. So even if you got those 2 things right and you mess up everything else, you get 2 out of 4 marks. You've got 50% of the question right just by getting the exponent right and your interest right. You then got a mark for getting your value of your investment after the 12-month period. And obviously, like I say, that final mark for your conclusion. So again, make sure you read your information carefully and you are substituting in the correct values appropriately. Because, like I say, even if you made some weird mistake on your calculator or you substituted into the wrong formula or something, generally speaking, you can at least get 1 or 2 marks for that I and or N value. Those are often what we call independent marks. So you get those marks regardless of whatever other nonsense might have been written down. All right, so not too tricky. Nice future value question. It's a prove that, show that, is this true sort of scenario. But future value, nice and easy. Right, again, I'm going to wait for you to take screenshots. Please ask questions if you need to or if you want to. And then we'll have a look at our next one. Okay. So this is now a slightly more complex question dealing with a loan scenario. I'm not saying always, but generally English. The loan scenarios are slightly harder. I think it's just the nature of the loan type questions and the fact that we can ask you for balance outstanding and stuff like that. They are generally harder, but again, if we read the question carefully and we understand what is actually being asked of us, it does become a lot easier. All right, so Tabo plans to buy a car that costs $250,000, 250,000 Rand. He will pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per annum, compounded monthly. All right, so again, we're not going to even get into the question, so we're first going to just analyze everything that we have. So first things first, we know what the cash price of our car is, but importantly, we also know that he pays a deposit. Remember, a deposit is an amount that you pay upfront, and what it does is it reduces the value that you owe. Okay, so a deposit will reduce what is owed. And this is the entire purpose of paying a deposit. If you can pay a deposit, that benefits you because it means that your loan amount will decrease. They cannot charge you interest on an amount you have already paid. And so, excuse me, and so paying a deposit is good. And if you can pay an even bigger deposit than what is required, let's say a store says a 10% deposit, if you can pay 20%, it just means that it decreases your loan amount even more and therefore reduces how much you owe on your loan. All right, so deposit, lovely. We've been told he's going to take out a loan to pay the rest, so we know it's a loan scenario. The second we see that word loan, or we understand that the context deals with a loan, we need to be working with our present value formula. The interest on the loan is 13% per annum, compounded monthly. Again, take note of your compounding period, very, very important. 13% per annum compounded monthly. We would have to take that 13% and divide it by 12. Right, again, I prefer to work with decimals, but it honestly makes no difference. You do you. So 0.13 over 12. That is what that interest amount is telling us. All right, now we can get into the questions. So the first one says calculate the value of a loan. Now this is taking you all the way back to grade 8, grade 9, when you did hire purchase loans. And this was one of the first things that we taught you how to do when we started with loans, understanding that if you make an upfront payment, i.e. a deposit, it will decrease your loan amount. Okay, so the value of a loan can always be determined by taking your cash price minus your deposit. Cash price minus deposit, that's how you work out the value of a loan. Now, granted, this is only a 1-mark question, but I am going to do a fair amount of working out so that we understand what we're doing. But obviously, it's 1 mark. You could go straight to the answer if you understand. Okay, so first things first, I want to work out my deposit, and that's 15% of the 250,000 Rand. That is therefore a deposit of 37,500, if my mental maths is serving me correct. Yes. What we now do to get our loan amount is we take the cash price of 250,000 and we subtract that deposit we just worked out. And that takes the amount down that he is going to loan from the bank to 212,500 Rand. So you're really only going to get a mark for this answer here, which fair enough, right? Because this is very much a grade 9 concept, but understand how to do it. You take the deposit and you subtract it from the cash price. You can do it all in one go. You can just write down the answer, 1 mark, no problem. Nice, Ayla, I'm glad we're on it. Okay, so this is now how much he is going to loan from the bank or loan from the lender, whatever the case is, to pay off the car. Again, you have already paid the 37,500 Rand. That's been paid. No legal loan contract can charge you interest on something you have already paid. And this is going to be important in the next question. So the next question says the first repayment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. All right, before we even get into this, there's a couple of things that we now need to remember when it comes to loans. And this is why I'm saying sometimes loans are a little trickier because there's a few things we need to remember. Okay, so first thing to remember is that loan repayments always start 1 month after the loan has been granted. Okay, I'm saying 1 month, but it's essentially one period, whatever that period may be. So if it's compounded quarterly, 1 quarter. If it's compounded biannually, I nearly said 1 6 months, 1/2 of a year. Okay, so it starts one period after the granting of your loan. Right, that is always the case for loans, always. For investment, we have scenarios where we can say he invests his money, but he starts his investment immediately, which means there's an extra payment into the investment. However, loans, there will never, ever be an extra payment. There might be less repayments, but there will never be an extra repayment. That's not how loans work. The second thing that we need to remember is that if your payments are delayed, okay, repayments are delayed. Guys, I can't speak English and write today. So let me speak and then I'll write. If your repayments are delayed by however long, the loan amount still gains interest. You still owe that money, and because it's sitting with a bank, it will still earn interest, which unfortunately means that you will have to pay back that interest as well, which is also why it's never good to default or to not make your loan repayments, because all it means is that you just end up owing more money. Okay, that's really the only outcome that then exists. So sorry, my bad. Okay, so now we have to write all of that down. Okay, so if repayments are delayed, loan amount earns interest. Okay, so like I said, that's the sucky thing about defaulting or not repaying your loans. It means that if you still owe money, interest is going to keep being added until you've paid it off. All right, so to visualize this whole scenario, I'm going to draw a very rough timeline. This is not necessary. I just think it's relatively helpful. So we know that this loan is for a period of 6 years. Now, it is the I'm going to get the words out at some point, guys. The interest is compounded monthly. So what that means is that 6 years has 72 months. There's my 72 months all the way at the end. Now, what we need to bear in mind is that it says the first repayment will be made 6 months after the loan has been granted. Now, remember, your repayments only start 1 month after the loan has been granted, or one period after. So technically, if this is 1 month, this is when the repayments should have started. However, they only start at 6 months after the loan has been granted. Okay, so we took out a loan. It took a month to be granted. And unfortunately, the first repayment only happens 6 months after the granting of our loan. What that means is, let's get another little color here. We'll get there eventually. What that means is that for 5 months, there is interest that we need to add on. Because even though you are not repaying that loan, you have still taken out that loan. It still earns interest for as long as you have that loan. And so even though you're not repaying it, unfortunately, we're adding interest on. Okay, so there's 5 months worth of interest being added in that time period before I start my repayments. The next thing I now need to bear in mind is that, remember, we're making payments monthly. And we start these repayments at this point over here. Okay. Now, we have got 5 months that we did nothing. And so what that means is that I need to catch up all my payments 5 months earlier than the 72. So 72 minus 5. I need to catch up all my repayments in 67 months now. Why 67? Well, again, the first 5 months of repayments you didn't make, but you earned interest. And a loan should never go on, or in our scenario, will never go on longer than the period allocated to it. Okay, you never want to have your loan for longer than necessary because you end up paying more and more interest. All right, so this question is a little tricky because we have to understand all of the stuff when it comes to repayment, when it starts, when it ends, etc., etc. And if we didn't, or if we had forgotten these first 2 bullet points up here in this beautiful green that I was drawing, it does make it harder. So again, loan repayments start 1 period after the loan is granted. And if repayments are delayed, we have to earn interest. It's just the reality. Right, I'm just going to take a break here. Does everyone understand what I've said so far? Because obviously now we need to do the calculation, but do we understand what I've said so far? Just give me a thumbs up or a thumbs down. Awesome. Nice, guys. Lydia?
Sorry, remember there's a mistake.
Oh, no problem. Cool. All right, guys, that's really, really good because I'm going to be honest. Sometimes when I get these finance questions, I read them like 3 or 4 times and I still don't know what I'm doing. So I'm glad we are all on top of it. Let's actually get into the calculation now. So we've got all this information. We hopefully know what we're doing. We can now just substitute into our formula. This is a loan. So remember I said right at the start, present value formula. Again, don't copy down the formula. It's not necessary. If it makes you more comfortable, absolutely go for it. So our present value formula is x, open bracket, 1 minus 1 plus I to the power negative n all over I. Negative n because you're repaying. And that will be what we use for those 67 months. But we first need to go and calculate how much we're going to repay with these 5 months worth of interest. Now, guys, because there's no repayments, there's no deposits, nothing weird is happening. You are quite literally just using your basic compound interest formula. So our loan amount, and this is again why it's important that you subtract your deposit, you only owe 212,500 Rand. You don't owe that initial 250,000 Rand. You've paid a deposit, so we can have a slightly smaller P value. It earns interest at 13% per annum, compounded monthly for a period of 5 months. Chuck that into your calculator and you get that. Unfortunately now, because you have not started your repayments immediately, you owe 224,262 Rand 53 cents. So still not quite the cash price, but close to. This is now what we are going to use to calculate our monthly installments. We know how much we need to pay off. We need to add all of that interest on. That's why our present value formula has that interest in the bracket. And we can now go work out what X is. Because remember, we want the monthly installment. All right, so P is your loan amount, the 224,262.53 cents. We're calculating X, 1 minus 1 plus I, 13% compounded monthly, to the power of negative 67. And again, remember negative 67 because we did not make the first 5 months worth of payments. So now I need to repay it over 67 months rather than 72, all over our I value, which is that 0.13 over 12. Now, guys, again, it depends how comfortable you are with your formulas. If you think back to like fractions from grade 8, grade 9, remember what this is saying is X times all of this stuff over here. That is what that fraction is saying to you. So technically what you could do is you could actually just take that whole situation and divide the 224,262 by it. Obviously, it's not the nicest thing in the world, but you can do it. If you don't want to do that, remember I said, rather do things step by step. So what I did was I worked out the value of that part of my fraction, because then it would just be x times that. Again, if you need to break it down even more, that's absolutely fine. And that came to 47,46, and there was a whole bunch of decimals. Now what I'm going to do is I'm going to divide both sides by the 47,46 to get my x, or monthly repayments, and that was 4,724 Rand 96 cents. Okay, so remember that x value should definitely always be a smaller value than your p value because it's your monthly repayments. And what we have done is we have taken into account all the interest that must be added to that loan, as well as the fact that the first 5 months were missed in terms of repayments. And so this is giving me my monthly repayment. Can anyone tell me what would happen to this amount? And we don't actually need to go and calculate it, but what would happen to this amount of x, so your monthly repayments, if this exponent had been negative 72? So if they hadn't missed any repayments, they started their repayments 1 month after the loan was granted, what would happen to the monthly value or the monthly repayment? Sorry if you can hear all the screaming, I do apologize. Nice, Layla. Siamtanda, nice. Good, guys, well done. It would be less. It means you've got more time to repay your loan. It means that you haven't earned all that interest. So you haven't got that 5 months worth of interest, which means that you owe less. You've got more time to pay it off. And so that monthly amount would decrease.